Welcome to our webinar on using OPC Server with Modbus devices for process control. This webinar will last about 20 to 30 minutes. I'm Maria Lamoni, Sales Manager here at ICP-DAS USA, and have Steve Sin from our Technical Support Department with me. If you have any questions at any time, please enter them into the chat box. We'll start with a brief introduction, go over OPC Server Technology and related equipment. We'll discuss data transmission using Modbus devices and writing client programs with NAPOPC Server software. We'll also discuss some easy-to-use software packages that we provide for monitoring and control that can also be used with NAPOPC Server. Near the end of our webinar, Steve Sin will be showing you how to integrate OPC Server with Indusoft SCADA software, HMI, and databases. ICP-DAS is a Taiwan-based manufacturer of industrial control, data acquisition, data communication, and wireless equipment. It was established in 1993, and ICP-DAS USA was launched in 2001 to support the North and South American markets. We have over 100 R&D engineers and work with them to add new features to our products, develop new products, and to support our customers. We are a Microsoft embedded partner, have ISO 9001 certification, provide ROHS lead-free equipment, and free technical support. We provide free online trainings every month on technology, equipment, programming, and software. Local systems often include data acquisition, the process of sampling, physical information like voltage, pressure, temperature, flow, and humidity levels. Data acquisition equipment is often networked together with programmable controllers that take in the information and trigger outputs for automation and process control. PLCs, PACs, PCs, and control equipment are networked together with different communication equipment like Ethernet switches, protocol converters, and wireless gateways. ICP-DAS provides total automation and control solutions for your applications. OPC Server is OLE, Object Linking and Embedding, for process control, which allows window-based software programs to communicate with industrial hardware equipment like PLCs, PACs, and I/O. OPC is an open standard and supports many different vendors' devices. OPC supports server and client connections. ICP-DAS provides NAPOPC DA server that can run on our WinPAC and ViewPAC Windows-based programmable automation controllers or Windows-based PCs. It allows for sharing data between Modbus TCP and RTU devices. It's free for use with our equipment, and there are USB dongles you can use with other vendors' Modbus devices. You can purchase the USB dongles. Process control deals with system design, equipment, and algorithms. It helps to maintain outputs based on conditions. Applications like controlling the temperature of a stream of water by controlling the amount of steam added to a heat exchanger, which will heat up the water accordingly, is a discrete type process control, which is used where the same product needs to be produced over and over. Discrete process control also includes motion and packaging type applications. Batch process control is used where you combine specific amounts of raw materials for specific amounts of time for production of products like glue. Continuous process control is where the system is ongoing, like wastewater treatment, chemical manufacturing, and plastic production. NAPOPC Server supports multi-thread communication, so there's a different socket used for communication with different devices. It helps streamline and speed up communication so each individual piece of equipment can be pulled based on requirements. NAPOPC can be run on a PC or one of our PAC controllers. You can network your Modbus devices back to your PC or PAC controllers with Ethernet cabling and Ethernet switches like our NSM208, which has a metal case. You can use serial cabling over RS485 for Modbus RTU buses. Databases, SCADA software, HMIs, also web applications, you can create your own applications or you can use existing software. NAPOPC Server, our software that we provide, can be used with our devices or with third-party Modbus devices. Process control deals with system design, equipment, and algorithms. It helps to maintain outputs based on conditions. Applications like controlling the temperature of a stream of water by controlling the amount of steam added to a heat exchanger, which will heat up the water accordingly, is an example of a discrete type process control. It's process control where the same kind of product needs to be produced over and over, like motion and packaging applications. Batch process control is where you combine specific amounts of raw materials for specific amounts of time for production like glue. Continuous process control is where a system is ongoing, like wastewater treatment, chemical manufacturing, and plastic production. NAPOPC Server can be used in all of these type of applications. NAPOPC Server supports multi-thread communication, so there's a different socket used for communication with different devices. It helps streamline and speed up communication so each individual piece of equipment can be pulled based on requirements. NAPOPC can be run on a PC or one of our PAC controllers. You can use Modbus devices and you can network them back to your PC or PAC controllers over Ethernet cabling with Ethernet switches like our NSM208, which has a metal case. You can also use serial cabling over RS485 for Modbus RTU buses. You can log data in a database and share data with NAPOPC Server. You would create tags in your NAPOPC Server software that match up to the tags in your database and specify the proper data format information when you set it up. The RS-232, RS-485, and Ethernet networks are commonly used system communication backbones. ICP-DAS's NS-205 and NS-208 are commonly used for industrial Ethernet communication and are used to connect Ethernet devices back to systems running NAPOPC Server over Ethernet. NAPOPC Server supports communication protocol conversion applications, so you can convert one protocol to another, like Modbus RTU to Modbus TCP, and you can use that with NAPOPC Server for communication with legacy type equipment. VxComm is also supported with NAPOPC Server, so devices like our i7000, RS485, and also Modbus RTU-based modules can be connected to our PDS serial to Ethernet device servers, and those PDS devices can be connected back to Ethernet switches, which are connected to the NAPOPC server running inside of a PAC or a PC. You can also use PCs running SCADA software to interface with the data from the NAPOPC server so it can be shared amongst everything in your application. You can also use wireless equipment with NAPOPC Server through cellular and other wireless gateways. So it's really handy for sharing data between devices. We provide many different I/O and control solutions that you can use with NAPOPC Server, including the i7000 serial-based I/O modules. They come in different kinds of input configurations, including RTD, thermistor, strain gauge, relay, digital, analog and current and voltage type configurations. The i7000 is a Decon RS485. The M7000 is Modbus RTU. The ET7000 series is Modbus TCP. We also have a PET series, which is power over Ethernet, so you can power them with our power over Ethernet switches. We also have PoE injectors, which can be used with regular switches. And we also have PoE splitters that can take power over Ethernet from a power over Ethernet switch, and it can put out 24 volts for powering different equipment. You can also use these on the Windows-based packs we have, like the WinPAC, the XPAC, also the ViewPAC. So this WinPAC controller is running a Windows operating system, either CE.NET 5.0. We are also starting to come out with more controllers than they have CE.NET 7.0. It has an FTP server for transferring files. HTTP server for publishing web pages. It supports ASP for JavaScript and VBScript. It also has a SQL server for data logging and supports a .NET framework. We provide a VCEP software with our WinPAC and ViewPAC controllers, and you can use it for remote communication and also for changing parameters and changing programs remotely, kind of like a GoToMyPC or a VLAN, like a remoting in to your, like a remote desktop. WinPAC has many different communication ports. It also has a port for monitoring with the connecting to a monitor. It also has 2 Ethernet ports. They each have their own NIC card. It also has I/O slots for cartridge-based I/O and communication modules, including digital, relay, thermistor, RTD, thermocouple, voltage, current, and strain gauge. It also has redundant power inputs for reliability. It can be expanded to support different I/O and different communication protocols. We provide racks and remote I/O. It can also be used with cellular modems and routers for remote communication. We do also provide some DCS system I/O for redundant I/O in case you need that. WinPAC is being used with NAPOPC for many different applications, including HVAC and building automation systems. This is an example, a real live example from our ICBDAS headquarters. WinPAC adjusts the temperature in the entire building based on information from the sensors, and it has a touch screen for controlling it and makes the office cooler. ViewPAC is really similar to our WinPAC controller. Again, these can both run NAPOPC Server for communication and data sharing between devices. The ViewPAC, the difference is it has a touchscreen on board and it has I/O slots on the back. There are also versions of our WinPAC and ViewPAC controllers that have Indusoft SCADA software right on board. We provide a free eLogger software for these types of controllers that run CE.NET 5.0. You can map up gauges, buttons, tanks, and other objects with actual I/O so you can see their status and monitor it with the touchscreen. It's very easy to set up. These packs can run multiple programs, so you can run eLogger, you can run Indusoft, you can run an IEC 611 program, you can run a Visual Basic program, and you can run NAPOPC Server all on the same device. So for Visual Basic programming, it supports COM, Component Object Model. The COM implementation from Visual Basic uses what's called an automation interface. The OPC Foundation supplies the source code of the automation wrapper DLL, which lets the VB access OPC servers and underlying groups and items. That's why you have to install the OPC DAC, Data Access Component software. More information on this is in the manual for NAPOPC Server. So after you install the NAPOPC OPC software, you're able to use the automation wrapper, which connects VB to OPC. This figure here shows you the architecture of the object model for the automation wrapper. And because the OPC server object contains group objects and item objects using collection, OPC browse objects allows you to access the item data through the pointer of the OPC server object. WinGraph is software that we provide for some of our ViewPAC and WinPAC controllers. It allows you to program in ladder logic, structured text, instruction list, sequential function chart, and also function block diagram. And it runs on Windows newer systems like Windows 7, 8, and 10. SoftGraph runs on our Windows packs that can run with WinGraph, which I just showed you, and it allows you to set up a easy-to-use HMI You can make up to 200 different pages in your HMI. It supports password security, animated graphics, alphanumeric text. You can use bars to show how much tank levels and pressure information. You can also use gauges and trend graphs. So this is a free software that we provide with our IEC 611 programmable controllers like WinGraph and ISOGraph controllers. NAPOPC Server can be used with PC-based control and monitoring software, so you can run software that's collecting data, data acquisition type applications for analyzing and displaying data and showing the results. You can use this kind of software with PACs, PLCs, and remote I/O, and you can also use different kinds of communication buses and protocols. One software we provide is free easy data logger software. You can show trend information, you can show gauges on a screen, you can show bar graphs that show the different measurements. You can also arrange a layout page which shows different objects like gauges, buttons, and text displays to show you the different kind of information you want to see. It also supports web cameras, so you can really customize the interface. And this is a free software that you can use it with our devices. You can also use it with other vendors' Modbus devices as long as you have one of our ICP-DAS modules in the network. Indusoft SCADA software is control and monitoring software. You can use it to generate customized reports, show status, implement control. Also, you can send email alarms and log data. We do provide a free hour of web-based training with purchase of Indusoft. The training can be catered around your application. You can create pages that show temperature data. You can also add navigation buttons that can take you to other customized pages. You can also make a page that has alarms. So when you are looking at temperature data, you can see just the different values that were above or below a set threshold. You can also show data with text, gauges, pictures. You can also use animation. It supports objects, so in case you do create a particular object, you can use that over and over again throughout your application just by copying and pasting it instead of having to create it from scratch. It does work with Google API Maps for remote monitoring and control, so you can see the status of equipment in different areas or see moving vehicles on a screen. Now I'm going to pass the presentation over to Steve, who's going to be showing you using the NAPOPC server with SCADA, HMI, and databases.
Okay, thank you, Maria. Today I will show you how to integrate OPC server with SCADA, HMI, and database using our NAPOPC STOPC data access server. We also have different NAPOPC server for other platforms. Today I will show you NAPOPC ST today and use PC as the hardware platform. For NAPOPC ST server, it supports all of our programmable automation controller, DCOM, and Modbus remote I/O modules. I will be using an PET 7026 data acquisition remote I/O module to read and write I/O data. This is the wiring diagram of my current setup. The module is currently connected to my computer with NAPOPC Server and Indusoft. Okay, let's open MiniOS 7. First thing to do is the configuration of the remote I/O module. I use MiniOS 7 utility to set my IP address, subnet mask, and gateway for the module. And we will do a search on MiniOS 7 utility, and the result will come up with the remote I/O module is connected, and then click IP settings. You can make sure the IP address and computer are in the same network. Now we can close this one and open NAPOPC server. This is the NAPOPC server. It looks like. Under Add, we can search modules. It has an auto search function for all supported ICP desk modules. For Ethernet I/O and WISE module, make sure to check the box Ethernet I/O or WISE, and then click Search. Then the PET 7026 will show up on the left side. It is a tree-type structure showing equipment in the device and group. When you click on the groups, like for example AI/AO, DI/DO, you will see some text representing all the channels. In this case, PET 7026 is the device, AIO, DIO, and latch is the group, and we see the text on the central. This region is the attribute description for each group and tag. All the attributes, even though hidden in the setting up dialog box, can be displayed in the table clearly. The top region is the tooth icon bar for the function often used. In order to read or write text, first click on the monitor button, and then you will see a real-time value here. We can write a different value by right-click the tag, then select property. Under read and write tab, you can actually write a value and click OK. So once the NAPOPC server is set up, we can now move to Indusoft. This is a demo program I made to show both analog and digital I/O status from the PET 7026. Let's run it. And as you see from the wiring diagram, I tie D01 to DI1. So when I turn on the D01, DI1 should also be on. So I also make some automation switch to make it nicer. For AO, I tie AO0 to VI5. So when I change a DO and make it 500, enter, it will change the AI5 also. Okay, now I will walk you through how to do the project using an NAPOPC. So let's make a new project. Let's make an NAPOPC demo. And then we use window local interface. OPC. First of all, let's make a new screen by right-click screen and insert. Let's make screen 1. I'm going to put a wiring diagram on screen to show you exactly how I wire. I will create 4 tags, which are DI1, DO1, AI5, and AO1. So click on the tag. Under graphic tooth, you will see here. Under active objects, you can see a tag. So let's put DO1 colon pound sign. We open this. So the panzer is actually the text I will put in later. And for easy, you can just copy and paste. And change the name. Next one will be AO1, AO0, and AI5. So the panzer representing the digit. And we do the same thing for all other tags. So now I will need to create a symbol for exit the program. So let's click on symbols and open up the system symbols. Look for the exit button here, and then paste it on the screen. So let's create a text for each I/O. So we can double click the text we just enter and click on text data link and enter the tag name. So this one is DO1, so I just enter DO1 as the name and close. It will ask you it does not exist. Would you like to create this tag? Then we click yes. So for digital I/O can only be 0 or 1. So we select Boolean as the data type. Same on other tag, DI1. So for analog, it is in integer, not Boolean. Last one is the AI5. To be able to change or write a value to output, I would like to make a text box. So under graphic, text box, and make a text box here. Okay. Let's move it around a little bit. I copy another one for AO. Okay. So this one I also need to link it to the tag. So this is for DO1. So just click on DO1 and close it. This one is for AO0. So I double click it, select AO0 as the tag. Okay. Now let's check the project text to make sure we created all the text. So all the text can be seen from the datasheet view under project text. Okay, now I can create my OPC server communication. So under COM communication setting, you will see different like driver OPC, DA. So OPC DA 2.05 is the one we need. So right click on that and insert. Enter the description. Let's put SV server identifier will be NAPOPC.SVR. So you can just double click the tag name and select what you just create. Select all the tags. So under items, you will see the device. Just double click on it, and then you will see the one we create on NAPOPC Server. We just need to select the one associated with our Indusoft tag. Make sure, so for DI1, we click on DI1 and select channels 1. So DO, channel 1, AO, channel 0, and AI5, which is AI, and channel 5. Make sure to save that after it's done. Okay. Let's run it and see if the value appear here. Okay, let's write run 1 to DO1 and see if it changes. So let's write 1, and then DI1 does change because it's tied together. And AO0 is connected to AI5, so I can verify by entering value and enter. So it does change to approximately 300. You can also create some other symbols to switch on and off. Just like the first project I saw, it has a switch and a LED light. You can do that from going to symbols, and then you can select different icons. And what you need to do is just link it to the specific tag. That's all I have today. So any question about NAPOPC Server?
We have a question from Robert. It says, I'm guessing the SQL Server version is the Express version, and yes, that's correct. On the WinPAC and the ViewPAC both, they have the Express version, SQL Server Express. Any other questions, you just please type them into the chat box. If you think of other questions later, you can also contact us by email, phone, or we even have a web chat on our website. So I guess I just want to tell you the next webinar training schedule that we have coming up on July 15th. We have a webinar on Modbus data acquisition with LabVIEW. Then on August 19th, we have a webinar on Zigbee wireless I/O pairing, trigger outputs based on inputs. And then in September, on September 16th, we have one on protocol converters for network interoperability. And I will, in the chat right now, I'm going to put the link for future, for signing up for future webinars. Otherwise, you can also send me the link. Otherwise, you can also send me an email. Thank you so much for attending, and have a great weekend.